Hello, everyone, and welcome to another complimentary Green Tech Media webinar. Today's presentation, The Road to Seamless Distributed Energy Resource Integration and the Stops Along the Way, is brought to you with support from our sponsor, Enbala Power Networks. I'm Elta Colo, an analyst for GTM Research, a Green Tech Media company, and I will be moderating today's webinar. Green Tech Media is an online publisher for information on the green and renewable technology industry. GTM Research is a market analysis and consulting arm of Green Tech Media. You can stay informed by reading the news on greentechmedia.com and find out more about our research products by visiting gtmresearch.com. You can also click the GTM icon at the bottom of your screen for more information about our company. Before we get started, I would like to take a moment to go over the screen in front of you so that you can make the most of the time we have with our speakers. You'll notice there is a dock along the bottom of your screen with several widgets. Some widgets that may be of interest. Download Slides has a link to download a PDF of the presentation. On the right side of the menu bar, you can find speaker bios. There's also a widget that allows you to share this webinar through your preferred social media outlets. Please note that you are able to enter questions at any point throughout the presentation through the Q&A box located on the lower left-hand side of your screen. We will have a 10 to 15-minute Q&A segment at the end of the presentation today, during which we will try to address all of your questions. To enlarge the slide area, just click on the box on the top right corner of your presentation window. Before we go any further, I would like to introduce today's speakers. We have Bud Voss, President and CEO of Enbala Power Networks, Pete Fuller, the Vice President of Market and Regulatory Affairs for the East Region at NRG Energy, Rich Barone, Manager of Demand Response at Hawaiian Electric Company, and Sharon Allen, the President and CEO of SCIP. Today's presentation will be broken down into 6 parts, starting with an introduction on the GTM research approach to DER analysis, followed by Bud's overview on creating a clean, sustainable, and distributed energy future. After, Pete will speak about the road to DR deployment, and Rich will give an overview of Hawaii's Distributed Energy Resource Management Initiative. Sharon will close out the presentation with a discussion on DR collaborations. We will conclude with a 10 to 15-minute audience Q&A session at the end of the hour. To participate in the Q&A period, you can enter that at any time via the Q&A dialog box on the left of your screen. The GTM research approach. The U.S. power system is undergoing a structural shift toward the increased penetration and use of distributed resources. Some territories are ahead of the game in regulatory guidance, planning and implementation reaching low and, in most innovative cases, moderate adoption of distributed energy resources. To maintain the growth of distributed energy, there are 3 primary areas where utilities, regulators, and third parties will have to invest, and that is distribution planning, grid operations, and market incorporation. Distribution planning considers the long-term maintenance and improvement in reliability and system resiliency. It is becoming an increasingly complex process in which decisions are made with respect to grid investments and possible deferrals through the use of non-wires alternatives. Deeper penetration levels of distributed energy resources are prompting enhanced planning tools and methodologies driven by data analytics tools for superior forecasting and simulation. As grid operators, utilities have the core responsibility of operating the grid safely, securely, and reliably. System operation requires managing real and reactive power, maintaining distribution equipment, maintaining power quality, and improving operational efficiency. DERs increase the distribution system operational complexity. Two-way power flows, ramping, and intermittency associated with distributed resources create the need for better monitoring, measurement, coordination, and control. Leading utilities are improving data quality practices for enhancements to GIS, SCADA, and DMS systems in preparation for the integration of distributed energy resource management platforms, dynamic DR tariffs, and distributed intelligence. In light of a future with high DR penetration, there's a need for an accompanying market structure that can accommodate the change in resource mix at the wholesale level. The Federal Energy Regulatory Commission has realized this need, putting forth a notice of proposed rulemaking in late November on the integration of energy storage into wholesale markets. The rulemaking requires each regional transmission organization and independent system operator to create rules for energy storage to participate in wholesale markets, recognizing the physical and operational characteristics of electric storage resources. Efforts across the country, notably those backed by New York's Reforming the Energy Vision, have created a foundation for wholesale market DR integration. Prior to starting the speaker presentations, I would like to pose a question to the audience. Will the results of the presidential election have a meaningful impact on distributed energy resources? You can answer yes, no, or maybe. I will give you a few moments so that you can input your answers, and then I will show the results. So the majority of you have answered yes, but there's another majority that thinks no. And so let's see what our speakers think. Bud?
Great. Thank you so much. Appreciate everybody joining us here this afternoon or this morning, wherever you are. I find that result quite fascinating, actually, because I think it sets a tone for most of the rest of this conversation as we begin to dive into the road and the path towards distributed energy and our future. We do truly sit today at this new dawn where renewables and high penetration of renewables are becoming more of the forefront of our future and certainly are in the conversation today. I like to look at this picture and think about what our world will look like just 20 years from now. Will we still be maintaining the same position we have today, or will we be in an entirely new place? And so with that high penetration of renewables, we have another quick poll question for the audience. If you're a utility executive or you're working with a number of utilities in the marketplace and understand their thoughts and thinkings about this topic, what keeps you awake at night? Give you just a few moments to answer this quick poll question, and then we'll go to the results. Great. Thank you so much for answering that quick question. And of course, as most of these polls go, when in doubt, sometimes you answer all of the above, which looks to be our most popular answer, which means we have a lot of uncertainty in our future. We will come back to this a little bit more as we talk to some of our other speakers today and what's keeping them up at night and their associated utility executives. But let's move on and talk about what we think this future actually looks like. At Enbala, we think about the fact that fundamentally, as we go through this change, two facts will become clear and evident. The first is our grid's going to invert. Generation resources at the end of our grid are going to become more prominent. And coupled with this fact is that they're going to be widely variable. Well, in our industry, we've gone through these kinds of transitions before. We've, in roughly looking at the 120-year history of our industry, we see about every 30 to 40 years massive transformations that occur, going from local grids to central station electric companies powering our cities, to an interconnected transmission grid, which was a huge revolution from the 30s to the 70s, to wholesale markets, which then decoupled our generation resources from the rest of the system, created price transparency, and now has opened up markets, frankly, worldwide, and to what we call today the grid edge. And as we think about what that transition is going to mean, we believe that it means in 20 years, the industry that we know of it today may no longer exist in the way that we know it. Supported by data from our friends at folks like Utility Dive and other research institutions around the country, they've surveyed utility executives and asked them what do they think their utility will become. 32% of them say they'll become a service provider or a network operator, and 84% of them say in 20 years our energy resources will be coming largely from distributed and variable resources at the end of the grid. So at Enbala, we like to think about the fact that we really truly need a new Grid 2.0 operating system. And what is that grid operating system going to look like? Well, of course, it's going to be intelligent. It's going to be distributed, matching the needs of our new distributed energy resources. It's going to be largely connected using technologies such as IOT technology and capabilities that we've never seen before around communications. It has to be secure. Security is becoming paramount in this new world. And of course, we're going to adapt to new business models. So today, distributed energy in action takes on really three forms, and we're going to talk more about this with our speakers here through the course of today. At Enbala, we think of our Symphony platform as sitting at the hub of very many activities that occur around distributed energy. And this pinwheel that you see of these activities starting in the lower left around coordinating distributed demand-side management resources, planning and location, trading, et cetera, was actually formulated by our friends at Green Tech Media as they started to look at all of the different impacts that distributed energy could have. We like to break this down into three fundamental buckets, the first being system planning, where you do a lot of work up front. And Elsa mentioned this before, looking at how do we plan our resources? Where are they going to be? How are they going to be coordinated with all of our other activities within the utility? To virtual power plants, where we're now using the assets and resources in a truly power plant way to dispatch and create blocks of energy and capability and capacity that can be used in wholesale markets or for regulated utilities. To then at the top of the diagram looking at how do we now optimize the network within the distribution system itself. And that's what distributed energy in action truly means. And we're continuing to learn and think more about what this new future is going to be. And I'm proud to be partnered here with a number of speakers who are going to talk to you about how they see that world. Rich Barone is going to be talking to you about what HECO is thinking about and how the Hawaiian Electric Company is embarking on rapid and massive changes within their distribution grid, but also among how they pair and marry that up with their traditional resources. We're going to hear from Peter Fuller at NRG looking at how these resources are working together for the initiatives of NRG. And then lastly, we're going to hear from Sharon Allen, who's going to talk about how we're moving our standards in our organizations and moving this in a way that the ecosystem itself can actually promote and foster this capability in the industry. Before we dive into those speakers, one last poll question for the audience, which is, what do you see as the biggest obstacle to building programs for large-scale distributed energy integration? I'll give everybody just a moment to answer that question before we move on. Fantastic. Thank you, everybody, for participating. Regulatory certainly rises to the top. And as it usually does in these questions, we find that regulatory hurdles are the thing that is continuing to cause concern and even holding back part of the industry. Well, let me quickly advance past my credentials and contact information if you would like it. We would certainly love to reach out and talk with you about what Enbala is all about. But I'm going to turn it now over to Peter Fuller with NRG, who can talk a little bit about what they're doing at NRG.
Thank you, Bud, very much, and thanks everybody for being on the call today. Thanks to folks at Green Tech Media and the whole team at Enbala for putting this together and inviting me to be part of it. Really appreciate the opportunity. I've left out a lot of the background slides on NRG, but just 2 seconds on that. You know, NRG is one of the largest owners and operators of traditional independent power producing plants across the country. But more importantly, and relevant to this discussion, we are committed to a customer-centric, customer-driven and renewable distributed future. And so we spend a lot of time participating in the regulatory environment and thinking about how we can advance that future. We're looking at what we call the 4-product future, which is driven by renewables for, raw kilowatt hours, storage, and controllable load to really help balance and manage the supply-demand equation, and a certain amount of traditional resources, just to make sure that we've got the balancing there. That's kind of the vision that we come at this overall question with, and included in that is a tremendous amount of resource at the grid edge and using the distribution system really as a platform. So I've got, as I move on a second here, I've got what I've labeled as steps to DER deployment and integration. I don't mean to imply that these are sequential. They're just facets of the puzzle. So please don't misinterpret that. They all have to work together. So let me move on there and get right into it. So I've got the obligatory safe harbor statement, which we can skip over. So as we think about it, and very much in line with the question that Bud just posed in the poll, it isn't just one thing, although I think I agree with the outcome of that poll that regulatory is probably the biggest and thorniest issue. But we see a number of things that need to be moving all at the same time, really, in order to move this forward. And so we think about it in these four buckets for convenience today. Just elementally, there are some hardware issues and some configuration issues that need to be addressed on the utility system. We no longer, or we are moving away from that hierarchical, top-down, one-direction system, and we need to have a much more networked, integrated, flexible, adaptable system. So we see it's very important that the utilities are working on AMI and data management to make that the tremendous amounts of data that you can get from AMI useful, make it available to authorized parties, back to Bud's point about security being critical. But once authorized, people, suppliers, and so forth need access to data in order to be able to service their customers better, attract customers, and so forth. From the utilities and aggregators and so forth point of view, and the RTOs, situational awareness and communications. That communications overlay and that sensing overlay of the physical distribution is so critical to be able to take advantage, frankly, of the distributed resources. If you don't know whether a section of a feeder is alive or disconnected, the default has always been that the DERs are disconnected. So better situational awareness, better communications across the distribution platform. And of course, what I find is missing from a lot of conversations, perhaps it's implied, but the simple element, not simple, but the element of protection and flexibility in circuit configuration, power flow, and so forth, that the old rules of power is always going to flow one direction, and if you get a voltage differential or you get a current spike or something moving the other way, there's a problem and you can trip a protective device, is no longer the case. So rethinking the way that utilities design, protect, and operate even what are generally radial systems is another key piece of this. Moving on to a little bit more of the regulatory construct and the business model construct is the idea of incentives, and the idea that in order to really make this work, it's got to be the case that utilities are not only, certainly can't be opposed or harmed by this kind of a future, and it really isn't enough, frankly, for them to be indifferent. We really need to look for ways to incent utilities to do the kinds of things that create this open platform, create the access for third parties, create the access for customers, and do it in a way that utilities actually do well and thrive in that environment. So we see very much that sort of neutral platform provider role as the key direction for utilities to be going. That we're looking at utility cost recovery structures, rate designs that reward them for being open and transparent, for rapid availability of interconnection, other elements that really go to servicing the customer desire and the third-party services that are going to flow across the network in all directions, and that those kinds of things are really where the utilities' incentives ought to lie. And along that road, we at NRG, coming from a competitive space and an independent power space, really strongly believe that not only for the opportunity for the competitive sector, but really to enhance society's best use of what we consider a fairly precious resource, the utility rate base, is to really think carefully in all of these regulatory conversations about managing or limiting the utilities' investments to the things that really have that unique monopoly utility characteristic, and to be very careful and mindful to provide opportunities for customers and third parties to invest their capital for things that can be handled that way. And as we talk more about it, we see this whole evolution of to the grid edge as being enabled by and enabling more and more of that competitive mode. So the third aspect to talk about is planning and how utilities, regulators, customers, third parties, all parties involved here think about distributed resources, not just as an afterthought, not just as a novelty, but really build it in as a fundamental element of the planning toolkit for the utility, so that it's right at the forefront. It's not that it's the only solution or has a preferred position over traditional T&D investments, but that it is right in the same conversation and is considered fully for all of its capabilities. We think it's extremely important that both the planning and the ultimate procurement or access of the DERs to fill those kind of needs is open, transparent, and competitive, and so forth. We're seeing a little bit of the evolution in New York, or we've talked a great deal about it under the REV proceeding, similar to the California, walk, jog, run model, where we're talking about, thinking about non-wires alternatives sort of as an RFP directed procurement idea, but also thinking ahead to, well, is there a tariff base, this feed-in tariff kind of idea that might work? Is there a transactive market at the edge of the grid that might work? So thinking along that trajectory, but in any event, trying to be open and transparent about how DERs can be valued and provide the T&D benefits. Again, quantification of those benefits and making sure that those are all visible and monetizable for the DER providers and the customers. And likewise, as I said before, for the utilities, making sure that they are incented to make this kind of thing happen and that they are not harmed as a result financially. And the fourth one really gets more to that, grid edge market, transactive grid kind of idea. But even before that, as we start down this road, and in the context of the FERC NOPR that just came out about storage and DER and aggregation and so forth, these are kind of critical questions and critically important to think about how we can move the value of DERs, whether deployed, within a facility behind a meter, in an aggregation, deployed at a somewhat higher level in the distribution system directly, or even more at the at the bulk substation level or what have you. But making sure that those all factor in and have clear access to all of the value streams that exist. The ability in the RTOs and ultimately in distribution markets for the rules to be clear, that information's available, that prices and values are clearly transmitted. the ability, the recognition that DERs can, in many cases, particularly storage, but other types, can actually provide different services depending on exactly the situation, on exactly what time it is. And the idea that aggregation and optimization of DERs really can, and in our opinion should be, a competitive service and not the realm of the utility or the RTO. Not that they can't ever do that, but certainly not exclusively, because as long as there are clear price signals and we actually drive to that kind of efficient, visible price, the ability of a third party, of a competitive entity, to optimize for the benefit of a customer, for the benefit of the utility, for the benefit of the grid, for other customers, that all becomes very workable in the kind of platforms that Enbala and others are talking about, where you can really see and manage the different objectives. And so to wrap up here, we absolutely see a tremendous challenge in all of this. The physical issues I've talked about in terms of the grid, metering, and so forth, the regulatory issues, primary and are very thorny and will take a long time to work through. Getting from the regulatory frameworks, getting the business models to work out, understanding analytics and communications, and ultimately, probably a little bit out of order here, ultimately getting the financial community comfortable that DERs deployed by customers, by third parties into these markets are effective and revenue stable and valid and good investments to make. And that's what's really going to drive us down the road. And from our perspective, it's not just that these are challenges that if we resolve them, this DER move to the grid will happen. We believe that the momentum is there, the inertia is there to move to the edge of the grid and for DERs to take a major role. So we think we have to engage and resolve on these issues, because as we talk to and listen to customers, we hear it. They want to be more engaged. They want to have more control. Technology, both in terms of the small-scale generation that we're seeing, as well as the technology of communication, smartphones, optimization platforms, all of that stuff is moving ahead and creating the ability for all this to happen. Costs are on a continual downward slide. The intelligence is moving more and more to the edge of the grid and the Internet of Things, and a continued interest in resiliency and local autonomy in the case of interruptions and so forth. So we see all of those drivers as not just an end state that we're hoping to get to, but really as the underpinning inertia to move us to actively grapple with and resolve all these challenges that we've laid forward. So with that, that's the end of my presentation, and I guess it's up to me to ask for responses on this poll question about where you and your company and your utility and so forth will focus for DERs going forward. So I will give you all a minute there before I move to the result and pass the presentation along. So it looks to me that, the issue of integrating and aggregating are very high on people's minds, and not surprising. With that, I think I'm turning it over to Rich Barone of Hawaiian Electric. So, Rich, take it away.
Thank you very much, and good morning/afternoon to everybody out there. I'm Rich Barone, the Manager of Demand Response here at Hawaiian Electric, and as a nice segue, because I'm going to talk to you a little bit about how we've been tackling the issue of an integrated demand response portfolio as a foundational exploration to aggregating the capabilities of distributed energy resources to deliver grid services. As you know, Hawaii is a very unique place for a couple of reasons germane to this discussion. Firstly, we do not have any wholesale market. And secondly, we are an island. So we really don't have a safety net. If you factor in on top of that, you've got 100% RPS by 2045 and a very high penetration of distributed generation PV at this point, and a market that's really not waiting for us to continue to explore DERs. We really have our feet to the fire. So a little background. We were ordered by the Commission, Public Utilities Commission, in April of 2014 to really explore this concept of an integrated demand response portfolio for the delivery of a wide array of ancillary services, not your standard DR. And so that's a driver to a lot of this. And on top of that, we realized that, hey, in addition to the customers themselves who are going to be engaging with these devices and participating in the grid with them, we also have internal customers. And I've heard it mentioned before in this call and other environments where you need to be bringing resources to operators and planners that are credible, that look like what they're used to working with, that are reliable. And that's really what we've undertaken. So following the guidance of the Commission and working with a special advisor, we followed a methodology that I think gets us to a good launch pad. First thing we had to do was really define what are the services that our system will be needing into the future. And in doing so, we had to establish what the quantities would be through a planning horizon on an annualized basis, and also what the value of those services are and would be. And again, this is in the absence of a wholesale market really establishing pricing for you. So as you can imagine, it's an ongoing and challenging exercise. With that as the basis for our work, we looked at those services and we decided to come up with an extensible regulatory framework. Sort of our toe in the water on this was to create a stepping stone towards a market type of approach. Knowing that we were going to be delivering a slew of programs via a variety of different channels, which I'll talk about in a minute, we knew we'd learn a lot and we'd have to change a lot. So what would be constant and what would be variable? The constant is the definition of the grid services themselves. So we wanted to make that the anchor tenant of a tariff structure. The variable would be maybe how these things get implemented, how they get verified, and so on and so forth. So what we created was a grid service tariff structure that underscores the services themselves that this portfolio is expected to deliver from the system perspective. We haven't gotten into the circuit level or distribution level value proposition at this point, but we'll likely get there. And then once we had those definitions, you could deliver those grid services through a variety of channels. And one channel is directly through the customer in a more conventional DR program offering, and the other is through turnkey providers. And I'll talk a little bit about that. But that became the framework, and we had to then see what's the market potential, which is difficult when you're dealing with new devices like distributed storage or electric vehicles, population uncertainty of those devices. So establishing a technical potential and then an achievable potential, a little more of an art, I think, than a science, but you work with what empirical data you have, and you come up with what that roadmap looks like. And once you know the potential, you can then run that through, as we did, production simulation optimization relative to an existing resource plan, to look at how this portfolio of end uses delivering a variety of services can fit nicely into an integrated resource plan and truly displace capital when possible, certainly fuel and operating and maintenance costs. As I mentioned, there's a variety of channels through which we can then deliver these services to our operators and make the offerings out to the customers in terms of how they can participate. The two principal mechanisms are, as I mentioned, more conventional DR program offerings, and for us those programs are termed as rates or riders, some of which we're looking to our DER docket for TOU rate structuring, and others are riders that we created ourselves that look a lot like historical DR tariffs. The other mechanism is an interesting approach, we believe, which takes the notion of a turnkey provider who goes out and really provides a full value chain, customer recruitment, enrollment, enablement, and delivers to us in a very similar construct to a power purchase agreement, what we're calling a grid service purchase agreement, which would be a multi-year contract with a turnkey provider for the delivery of said services. Where we are now is the few of the big pieces. Currently, we are in what you might call implementation phase 1, where we're rolling out a number of demonstration projects delivering 3 of the 4 services previously mentioned. We're working on developing that GSPA pro forma contract structure for Commission approval. We are finalizing our portfolio for February 10th filing, and we're awaiting decision on our deferred accounting treatment of our DRMS, which, as you'll see, is more of an evolving application into the distributed energy management system more than a conventional DRMS. This represents the 4 system-level services that we're aiming to deliver. Capacity is more of a scheduled capacity service, and it is much more than your standard load peak shaving. It's load shifting. It'll be building at times. It'll be shaving at times. It'll be effective shifting. Fast frequency response is an autonomous function that deals with frequency detection and near instantaneous response at the edge. Regulating reserves up and down are conventionally defined as reg up, reg down. High telemetry, aggregating a portfolio of devices to replicate, if you will, what a generator looks like to an advanced generating control system. And then finally, replacement reserves, which look a lot like a 10 and 30-minute non-spin service. I alluded to building up this market approach. Where we've gotten to thus far is we issued a grid services RFP about 18 months ago, received 25 responses. We've down selected to 9 shortlisted vendor teams, to whom we've reached out, and those shortlisted vendors were afforded the opportunity to participate in the demonstration phase. Likely, once the GSPA is finalized and we get approval to advance with our portfolio, we'll secure through GSPAs what we have on the table right now. We'll look at our projections for the portfolio, and we'll do some self-administration, but we'll also continue to roll RFPs forward is the current plan to fill out our program portfolio targets. Long term, a lot of different directions this can go. I think in the long run it probably sets a table for something like a transactive system. But there's a midterm play, I believe, that if we have market liquidity demonstrated through these efforts, we can certainly look at taking more of an auction approach, something that looks a little bit more like wholesale markets and some of the ISOs. We also plan to engage with self-aggregators. We've got a few big ones here in Hawaii, whether that be the DoD or University of Hawaii, the Board of Water Supply, and Department of Education. These are all what we would consider self-aggregators. We'd look to engage with them directly, and then they in turn would work with a technical coordinator to help sort of put all the pieces together. It's a potentially large chunk of our portfolio takes place with these partners. Where we are in the demonstration phase, I'm going to give this short shrift, but we've got 6 different of the 9 shortlisted vendors, 6 different teams providing these 3 services. The fast frequency response can be extended and prolonged into a non-spin type product. And so we'll try to capture a little bit of that in that service delivery. These are 6-month projects that look to serve as a gateway as we await overall portfolio approval. Lessons learned on technical and operational efficacy should inform how we engage in the GSPAs and how we ultimately deliver these services. And our instrument for doing so, which I'll talk about in a minute, will give the operators and the operating systems that visibility. We're looking at a variety of end uses here. Electric hot water heaters are a big deal in Hawaii, but we also expect to work with a lot of distributed storage and electric vehicles, among other things. We've gotten here through a number of transparent and collaborative stakeholder meetings where we've brought a lot of the vendors together, customers, policymakers, regulators, of course the vendors themselves, And we've really worked to incorporate the feedback we've collected through these engagements as we evolve our portfolio and our, if you will, our go-to-market or commercialization strategy for that portfolio of services. Just concluding with our DEMS, Distributed Energy Management System, some of the functions look similar to what you might see in the DRMS, especially on the administration side. But the aggregation and forecasting of dynamically transitioning services is a huge part of this because those forecasts will change. And at the end of the day, you want to make these programs credible to system operators, and they're going to need to know what they're going to get, when they're going to get it, what's available, what's impacted by what they've already dispatched. Measurement verification is going to be a big part of this as well, especially if you're dealing with settlement issues with respect to those aggregators. We're really deploying this as a system of systems approach where upstream, our DEMS becomes a vehicle for the abstraction of all those program rules and really taking the services and making them available either directly to operators or upstream to the EMS. And down the road, when we have things like an ADMS in place or other distribution level visibility, status availability, and control of distribution networks, this DEMS becomes a conduit of actionable information. Finally, dispatch, I kind of alluded to this, but in some cases there's going to be autonomous function of services, but of course then the forecast and availability needs to continuously be updated. In some cases, operators will have an action that they can take for more of the planned type of services. And then, of course, when you get into things like regulating reserves, that's going to have to be a system-to-system transmittal. So this is just a simple snapshot. If you look at the four services, the role that the DEMS plays, obviously administration cuts across all four. But if you look at dispatch, I've kind of redded that out in the area of fast frequency response. And then, of course, you get into the pricing-related programs. There's no action per se, but you are sending price signals. The bottom piece just talks about the issues of how you take these services that are using the same end uses and transition them from service availability to service availability based on event-based utilization. And that is a big part of what this orchestrating, integrating DEMS application will do for us. And we do believe this scales into a number of different future realities as you continue to utilize distributed energy resources in our system. That concludes my presentation. I think at this point I'm going to be transitioning or handing the mic over to Sharon Allen, and she'll take you the rest of the way. And thanks so much for your time.
Thanks, Rick. On the closer today, we absolutely want to hear from all of you. So hold on, take a swig of your coffee for you on the West Coast to our morning, and Coca-Cola on the East Coast, because I'm going to power through my slides because we absolutely want to hear from you. So SCIP is a nonprofit, and I have the pleasure, and I'm very fortunate to work with a number of you guys on the phone line. And I'm going to focus on just 3 of our projects where we have been working with many of you on the phone and how they touch and what are those projects about and how they're related to distributed energy resources. Because we know that within our industry today, change is happening, and we can't do this alone, and no one company can do it in a vacuum. And so I'm fortunate enough to work with a number of you folks on a few of these, which I'm going to briefly touch on. So the first one is the Grid Management Group. I was approached by some utilities to bring this group together. What we've done is we've brought IT and OT and strategy folks from utilities across North America, and we've been focused on what is the impact on systems as a result of distributed energy resources. We've been meeting since Distributech. And the way that the group has been focused is each month we have a topic, and we spend 8 hours on that topic on what are the requirements, what are the impacts of our system. So we have focus, we bounce between East and West Coast. We always have a host utility, and we've been going through what are the requirements and what are the changes in systems in terms of requirements as a result of high penetration DER. The outcome from this is in 2017. So we will have a meeting January 30th open to any utility who's going to distribute tech on Monday, January 30th between 1 and 4 to go through sharing some of the socialized requirements, which has been put together based upon some RFIs, RFPs, various utilities in North America have, and putting those things together. We plan to open it up to the ecosystem, which means probably around April or May, we will have a meeting where we'll inviting consultants, vendors. We have met with government to understand some of the national lab projects, and the outcome of this is the requirements will be used for sourcing by various utilities. So when I say we're looking across the ecosystem, you can see we've dealt with FLISR, we've dealt with adaptive protection control, we've dealt with microgrids, and what the intent is to be able to put out new sourcing from various utilities to those of you in the market. So that's one project. The second project, Duke came to us, and as Duke had looked at, they clocked actually what was the round trip time from inverters to their head-end system to do the computational cycle and then back out for control, and it was about 40 seconds. And that was causing them somewhat of a problem, which got them focused on how do we move more sensing and control closer to the edge rather than everything having to come up into the enterprise and do a round trip back out to the field. And thus a program we called OpenFMB was birthed. And what OpenFMB is it is a framework that supports management and control of distributed energy resources such that we're doing it close to the edge in the field. And what it enables is a local data exchange at the circuit segment. And this work resulted in us creating a standard which was passed by NASB in March of 2016. Last month, we've brought up an open web developers website so that you can have source code and that we can enable various vendors and enable those of you in industry to be able to embrace how to utilize using open standards to be able to move more sensing and control to the field. The last project I want to touch on very quickly is one that's called Orange Button. This is another program that we are working on that enables distributed energy resources. Our focus is on reduction of soft cost. And when I refer to soft costs, we're looking at what are some of those points of friction in terms of grid integration, O&M, financing, real estate, and deployment. We have about 300 companies who are participating. It is free. It does not require any funding from any of you that may be interested. Our overall objective is to define some of those data interfaces such that we can reduce some of the soft cost over deployment of various DER. So I've gone through that rather quickly, but there were 3 programs. It is across the ecosystem. OpenFMB is open to utilities and vendors. It is a collaboration role to the field. The grid management team is utility only right now. We'll open up to vendors and the broader ecosystem come second quarter next year, and Orange Button is already open to all players. At this point, we want to open up the lines so that we can have a dialogue with you and hear what's on your mind. And those of you, I'm going to turn it back to Green Tech Media. Let them give you instructions how you can post a question.
Thank you very much, Sharon. So now let's move on to the Q&A section. We have plenty of questions come in, but I'd like to remind everyone that you can still submit questions using the Q&A module. So as a first question, I'd like to ask, start with Bud, and let's see, will the future platform that enables effective DER to be used efficiently be open source via an imposed standard, or are you expecting to see something, beta versus VCR type of battle?
Well, I think that, thank you for the question, and I think what Sharon just touched on with the work that SCIP has been doing, particularly around that Open FMB project, what's really fascinating about that is that they're not saying how the platform has to work on the inside, but they are saying we need to have open and transparent interfaces for the data flows and for the information and the control signals that need to flow in this future. And if you think about it, that's really where typically most of these integration challenges lie, is in how do you put all these systems together and actually have leveraging open standards as a way to make integration and ultimately adoptability of any platform to be easier. So that's how we think that it's going to evolve. There's certainly core elements to anybody's platform in this space, whether it's their specific algorithms or specific ways in which they begin to optimize and control these resources. But certainly the data flow and the leveraging of IoT technology and open standards needs to make this much, much easier in an open way. Sharon, do you have anything you'd want to add to that in the essence of SCIP?
Yeah, I think what you say is spot on. As we look to have more participants, depending on where they're at, whether they're a software or a hardware vendor, having clear definition of how they can use IoT technology. If you look at a lot of our standards in the industry, I think the biggest thing that you'll see that's different as we begin to embrace more in the field, we'll see more bus structures. Today, a lot of our protocols have been around 15, 20 years. They're very master-slave, which is not always conducive for low latency. And as we start to look at how we better manage under frequency and voltage so that solar doesn't mask when we other feeders to trip from a protection control, that having new data interfaces that enable a bus structure as opposed to a master slave is really where we see the shift going into the field.
Great. Thank you, Sharon. So I'm going to continue with questions here. Another one of our listeners asked, what are some immediate steps that electric utilities can take to lay the groundwork for DR growth and optimization, absent PUC mandator levels of penetration in certain states like California, Hawaii, and Nevada are experiencing? So maybe we can start with you, Rich. You can give us your perspective on this.
Yeah, thank you. We're not entirely absent of regulatory guidance, but I would say if I were to take a step back and not have that driver, I may proceed in a pretty similar manner. So there's two real functional steps you can take. I think firstly is to do your best to assess what types of services that these collection of devices can deliver. Make sure that that's aligned with your system needs, because I do believe you have an internal customer with both ops and planning. But also do as much as you can with working with those devices out in the field, both in terms of delivering the services to establish the technical efficacy and then, of course, the operational efficacy. In process, you'll learn a lot about the market risks, what are the true costs, and then, of course, finally, you'll be playing with some of the telemetry and communication challenges I think Sharon alluded to, not just temporal requirements, but sort of standardization. So I think there are some real concrete steps that you could take to try to move the ball forward. All of that information would in turn inform any regulatory endeavors thereafter.
Great. Thank you, Rich. Pete, do you have any comments on this?
No, I think that's really it. I think I would again look at as Rich described, or maybe more organically or more widespread, but it's probably the hardware kind of stuff, which obviously has a regulatory overlay for a utility that's trying to make investments in AMI, in better controllability, visibility into their system. But I think those are certainly some key elements that utilities could pursue, along with integrating the DERs into their planning, and where they're cost effective compared to a traditional T&D investment. seeking regulatory approval of that. And again, you gain the benefit of the operational experience that comes with that, and build the environment that can lead to more and more of it.
May I just add to that comment? This is Rich again.
Of course.
Peter makes a good point, and I meant to allude to this earlier. There's this hurdle, I think, maybe, I don't think it's just here, right? I think it's at a lot of utilities where you have to demonstrate not just to your operators that this can be used, but frankly to your planners. This collection, let's call it a collective resource, has to have sufficient credibility to be given credit in an integrated planning exercise. So some of the measures that Peter has alluded to and that I spoke to earlier help you get up that learning curve and the credibility curve with your not just operators but planners, so that you can actually incorporate these resources fairly into your future plans.
Great.
And
thank
this
you.
is Sharon.
Go ahead, Sharon.
I just want to pile on and add to, on top of some of the things that have just been said. When I look for how you can get involved in what you can do, what I've seen working with the number of utilities I am is get engaged in some of these collaborative efforts. And what we've seen is a lot of the investor-owned utilities and some of the unreg side are sharing how things are working and how they're setting up those programs, what their findings are. We've seen some investor-owned utilities actually sharing some analytics and tools that they have developed with each other on where to cite things most effectively. And so if you're looking for how to learn without going through the ramp and steep learning curve yourself, get involved in some of these collaborative efforts with your peers.
Great. Thank you all for answering. There's another question here, just to shift gears a little bit, and Sharon, maybe you can start by answering this. How and if is balance going to be achieved between the C&I and residential markets to ensure fairness in the DR marketplace?
Some of that, so where I would say we have been focused, we have not been as focused on the regulatory framework and instead been more focused, how do you enable the technology such that there is the ability to provide control insight, which opens up the ability for third parties to come in, such as aggregators, to build businesses around that. I think fundamental, though, for some of the aggregators and some of their residential offerings geared towards residential customers, there has to be a business framework for them to operate in such that it would be conducive for them to create an offering to go after that market. And that needs to vary state by state in terms of what their regulatory backdrop is. So I don't know that there is one simple answer to say how that can be achieved. It's really going to be on a state-by-state basis.
Great. And I'd like to bring it back to Bud, and then maybe, Rich, you can tell us a little bit about the Hawaiian experience here for one of our last questions. How important is demand response as a critical component of DERs?
Great. Thank you, Elta and team, for supplying such wonderful and great questions. I think, demand response, we're in a very interesting state, I think, right now in the marketplace, because if we look broadly, not just North America, but even Europe and other parts of the world, demand response is the existing mechanism that we have as a way to monetize assets and resources that can be used in various markets, whether it's a wholesale market or a vertically integrated utility. We've educated our regulators and policymakers that demand response is a valuable resource, and so therefore it is now a way to actually monetize them. I think one of the challenges we have in this industry, though, is that we're now going through this transition of how do you move from a demand response resource that's used 20 or 30 times a year for a couple of hours on a day-ahead basis or an hour-ahead basis, and actually turning it into a real-time virtual power plant. And the market is going to embrace this transition. It's actually going to, I think, be forced through this transition of how do I now use this resource as an always-on, always reliable resource that can be dispatched just like any other power plant. And that was the promise of demand response at the very beginning. And so I think we're now seeing this come to fruition, and it's great to see entities like HECO and many others around the country actually embrace this and say, yeah, demand response is still the concept, but you look at the types of resources that Rich is promoting here. They are fast-acting, grid-related resources, just like you would use a power plant for in the context of demand response. Rich, how about you? What do you think?
Thank you, Bud. I think that captures a lot of what I would have said. I think the perception is that DR is a hugely important lever in this market. Where I struggle in communicating that is sort of the historical interpretation and definition of demand response. I tend to define it kind of broadly as the intended modifications to consumption patterns. Now, that's based on existing or expected grid needs. We've been relegated historically by certain technology sets and communications to a one-way rather than two-way and so forth that have relegated the delivery of a service to kind of narrow band of services. But as Bud alluded to and I've portrayed, we're looking at a full spectrum of ancillary services. The end uses that are going to be relegated to delivering those services are going to have a lot more flexibility and a lot higher expectations, and in turn, the value will be higher, hopefully. But these populations of devices, the lines get real blurred. If you think about it in the context of historical DR, the value is kind of low because you actually don't have the capacity needs, especially with all the renewables. It's just it's the variability that creates the need. So demand response's value becomes that of flexibility, that of load shifting, that of fast responding. That value chain gets bigger and bigger and bigger, and the more you have penetrations of these technologies, it's almost as if you're taking the populations that are growing and in some respects creating challenges, and you're using those very end uses to help, and the combinations of them to help mitigate the challenges and variability created on the grid. So in that context alone, demand response as the programmatic opportunities to leverage these devices is extremely important for extensibility into the distributed grid future.
And this is Pete Fuller. I'd just like to pile on to that a little bit. I think if we think about demand response as, you know, your father's demand response, I think Rich described very, very eloquently why that's, you know, a thing of the past. And what we need to be thinking about and do think about is a much more sophisticated view of what the end-use devices and purposes are, and how, frankly, in much more subtle and sophisticated ways, we can manage the consumption in a building, in a home, in electric vehicle charging, what have you, and, you know, shape it to better match the ability of the supply side to meet it. And to me, that is, you know, absolutely demand response writ large, and is a huge piece and a huge element of what we think about when we think about distributed energy resources. The, you know, the thermal and other storage capability, load shifting capability that's in the building stock and the usage elements that are out there now, and the increasing sophistication that we have to be able to analyze, control, and respond to system conditions.
Great. Well, I think our time is up for today. Thank you all for all of your wonderful insight. And in closing, I'd like to make a note that we'll archive this webinar at greentechmedia.com for 3 months. And I'd like to thank our speakers today, and thank you to all of you for listening.